Hello everyone, I'm Akhil Reddy Cherukpalli. I have chosen the topic energy efficient artificial intelligence over a virtualized cloud fog network. So basically, virtualized cloud fog network is categorized into three modules like network architecture, system model, and problem formulation and MILP model. From the cloud fog architecture, it comprises four main layers we can see in the picture. There are IoT in the end devices and access fog and the metro fog and the cloud data center onto the top. So IoT end device are at the bottom. We can see IoT zone 1 and IoT zone 2, and these are usually called as edge network, and they are connected for each other for the metro. And then we have a passive optical network which comprises of ONU devices, and they aggregate the traffic from the IoT layers towards the OLT device. And then we assume a AF node connected to the OLT, you can see on top. And then the MF node is connected to aggregation Ethernet, we can see at the metro switch. And then the small organizations end users can deploy their fog units at any point in the IoT end zone. And then in the IP layer, high core routers are used at each node to aggregate network traffic from the metro network. And then we have the VSR. It comprises of multiple virtual machines interconnected via virtual links. And then we have assumed here the output nodes consume negligible power due to their workload, and when compared to the virtual machines that abstract the hidden nodes. And then basically the importance of the input node is the placement of hidden nodes can be influenced by geographical distribution of the source nodes. In this picture, author developed a model to optimize the placement of virtual deep neural networks or virtual service requests. They consider into every virtual machine, and they represent a layer of the deep neural network model that has a demand for processing and networking. And then we have the cloud data center on the top, and then it goes to the metro fog, and then have the access fog. And we can see the virtual machine, it's a directed graph, and the VSR is represented directed graph. And we have clearly it shows the key variables used to establish virtual links to achieve the intervirtual machine communication. The following tables represents the first, the processing hardware used in the MILP model, and the networking hardware used in the MILP model. And we have the maximum width and the efficiency, what all the devices used in it. So we can clearly see in the picture bit rate and everything. So it's mixed integer linear programming model. And we have the metro switch in it, and the metro fog server, access fog server, and CDC, what all the device data center and IoT. And the first device we have previously discussed in the picture, one ONU device, and the maximum width. And then so for the power consumption, we use two different formulas, which is the first one is the network power consumption, and the next one is the processing power consumption. And from these formulas we categorize every category into a separate graph, so that we can see which one uses the most and which one uses the least. The current graph explains about how many number of VSRs we have used, virtual service requests, and then the power consumed by it. So the horizontal axis it displays like number of VSRs, and the vertical axis display like power consumption. So we have like 4 different ones, like the data center and the access fog, metro fog, and the mixed integer linear programming one. So we can see the graph, like for the MILP it has raised down suddenly and from 19 to 20 for like certain power consumption, and we can see like metro fog has the highest power consumption over here. The first bar chart represents about the mixed integer linear programming one, and the second one is access fog that we can see like previously we have seen in the graph. So it's a clear representation of like the power consumption and the number of virtual service requests used. The third one metro fog, and the last one data center. We can see the differences between the networking and processing for every 4 of these kinds, and we have like which one use the more power consumption by the processing one and the networking one, and they included like the virtual service requests too, like how many of them are consumed. So the paper is solving like mainly to establish like a connection in response to like how like increased interest like in utilizing the collective capacity of localized device at the edge different, and then where it is neglecting like it takes place to for the cloud processes, and then it addresses like virtualization approach by the virtual service request it's embedded, and then it represented the deep neural network models, and then we have like it has categorized like 4 different models, and they showed like power consumption for every category, like metro fog, access fog, and then CDC mixed integer one. The related work done by the author like it's basically fog computing refers to the extension of the cloud computing, and it consists like many edges. It links to the physical devices, and those nodes like are like far away from the device than the CDC centralized data centers, and then they give immediate connectivity to the devices. The use of the CDs are like to give the immediate connection only, and these like used over here. Authors like sincerely analyze like how deep neural networks have revolutionized recently, and then they provided a like future further understanding of how the deep neural networks are being deployed in many applications, from like autonomous applications, and it helped like to detect cancer signs that surpass the human accuracy. And then they have also provided like a clear proposed fog architecture model, like showing how it will work. They're showing like the edge network where we have used the IoT ones, and the access network, metro network, which are all connected to for the metro, and the access fog, metro fog, and the connectivities through like the CDC and everything. This all the connection by using all of these networks, and they showed like how it works by working all together. And the authors have done like experimental research which was like centrally concerned with constructing research that is high in casual, and they also conducted the experimental designs like which provides highest levels of casual validity. And the findings of the researchers are like to show functions and constraints applications of the notations, and mainly the 4 layers of network, including like IoT, Internet of Things, metro fog, access fog, and cloud data center. The network architecture has provided, and the connection like all together the architecture has provided like the connection between everything together, and they showed like how complete a picture will be in the architecture. And then the author found like the cloud data centers and the new power consumption strategies, like where we have seen in previously in the pictures like 4 different types, the network and processing types for every category, and this is due to like IoT Internet of Things layer computation, and access fog and metro fog nodes are never utilized despite like their proximity to Internet of Things. So in my opinion, like there are few things to improve their efforts. Initially I would ensure like I provide like clear steps to rub when installing the structures to prevent relying on assumptions. So and then of in like results and conclusion, they assume the ideal position is associated with the application, and the assumption rate is like less 3%, which is likely to undermine the outcomes and projected result. And then in system model, they assume the cloud fog network architecture was fully virtualized in multiple heterogeneous workloads, and then processing can be done on considered processing layers only despite the hardware heterogeneity. And like to help like minimize this, clear process would have been shown to understand like how the structures are set individuals may find, and it may like find hard to set up cloud fog architecture too. And then the virtual service requests embedded across the cloud fog architecture and the total power curve. Reference. Thank you everyone. If you have any questions, please let me know in the chat section.